Okay, it's already 7 minutes past 12:30, so I will be starting the lecture. Let me share my screen. Here we go. Okay. Last week we have worked out to test the difference between two and population means, considering when sigma square and sigma 2 square are known, but this time, so I copied this from the previous lecture, so they will be unknown this time. This time, number 2 is both unknown. Number 2, yeah. When sigma 1 square and sigma 2 square are unknown, what we do, let's see. Let's recall the previous lecture, the hypothesis we constructed for testing between two population means. I think I heard something. Do you see my screen?
Yes, teacher.
No problem. Do you see what I'm writing? Testing the difference. You read it?
Yes.
Okay. Fine. Once your claim telling you that the first mean population is less than the second mean population, when there is a claim where there's a statement within the exercise of the question, you will have to include the claim within the alternative hypothesis H1, and we call it left-sided. Or you can also interchange this one by taking mu2 to the left side, by subtracting mu2 from mu1, and you get it mu1 minus mu2 is less 0. So you could either construct the alternative hypothesis in this way or this way. I prefer basically the universal representation. So if you have the left-sided hypothesis given this way constructed, you will automatically construct the null hypothesis as in the opposite direction of mu1 less than mu2. So the opposite direction would be mu1 greater or equal to mu2. As a result, so you can also build the null hypothesis in this way. So since if this is a left-sided, the right side you will change the sign, the comparison sign from less to greater sign, and for the double-sided or two-tailed statistics, you will construct the alternative hypothesis mu1 is not equal to mu2. Basically, when if your claim is whether there is a significant difference, so if you see that statement, you will construct the alternative hypothesis to be not equal. You will understand from the exercise, from the question, whether you're going to construct a double-sided, left-sided, or right-sided. So it's easy. If the statement is telling you that whether there is a significant difference between the two population means, then you will construct the double-sided. If it tells you that whether the first mean population is less than the second, so you will construct the left-sided. And what it says that the first mean population is greater than the second mean population, and you will have to construct the right-sided hypothesis. So we have mentioned this statement in the previous week also to test such hypothesis with alpha level of significance. There are some conditions. So the first condition we have done it already for this is it was known, but this time today we will be working when sigma 1 square and sigma 2 square are unknown. So the test statistics we will be using is completely different this week. The test statistics you use the T calculated statistic. It's not Z calculated, so this time it's T calculated, and you have x1 bar, x1 bar minus x2 bar. So this is common from the previous week lecture. You see in the numerator part, x1 bar minus x2 bar is okay, the same. The denominator part of the test statistic is different. Let me show you. Within the square root, we have S square pooled variance. We call it pooled. One reciprocal n1 plus reciprocal n2 within the square root. So that's the statistics. This is the test statistic we'll be using for testing such hypothesis, where we know from the previous week x1 bar, x2 bar, x1 bar and x2 bar are sample means. Sample means n1 and n2 are sample sizes and we need to define what the pooled variance is. The pooled variance is not given mostly. You need to determine it yourself. And the pooled variance, let me show you how we determine the pooled variance. The pooled variance n1 minus 1 times s1 square plus n2 minus 1 times s2 square, and this is divided by n1 plus n2 minus 2. That's the pooled variance. You perform the calculation of the pooled variance by this way. Okay, this is the test statistics. Let me box this one to you. Frame it to the box. Yeah, this. Okay, you use the pooled variance is calculated by this way, where S1 square and S2 square are sample variances. Sample variances. S1 square, I'll just write 1. This is, you have learned it, the variant sample variances already. Maybe I have written it already. The sample variance for the first sample, this is 1 divided by n minus 1. This is xi minus x1 bar square. This is I from 1 to n. So this is the way how you perform the calculation of the first sample variances. And the second sample variance, all you need to do, you will, I'm mistaken here, this is, I have forgotten to include the subscript of n1, n1. So if you're using S2 square, for S2 square, you will change 2, and this is going to be 2, and that's going to be 2, 2, and change this one to 2, and that's it. I don't need to write the sample variance for the second sample variance. No need for that. Okay. Okay, the degree of okay, it's easy to calculate the test statistics. Once you calculate the test statistic to test such hypothesis, you need to compare that value, the t calculated value, with the critical value from the t distribution table. So the t distribution table basically needs the degree of freedom. So we need to determine the degree of freedom, degree of freedom, which is n1 plus n2 minus 2. That's how you determine it. So the critical value is t degree of freedom, df, and you will have alpha for one tail, for one tail distribution. Or for one tail test statistics, you can also let me change it in place of the distribution, one tail hypothesis. Okay, you will use alpha level. Otherwise, you will the t critical. You'll use equal t degree of freedom, the t distribution, and you will divide alpha by 2, and this is for two tail. Hypothesis. I'll take it to singular hypothesis. Okay. So that's how you do it. The comparison we make is exactly the same as what we did in the previous week lecture. Let me write an example, establish an example. Okay. I don't know how many of you have taken the course at the moment. There are only 2 people watching the lecture. Let me make an announcement for the next week lecture. I already mentioned in the previous week lecture that I won't be able to lecture on Friday, next Friday. I'll be out of town, so instead I will be teaching on Tuesday. I had a discussion with you last week on Monday, mentioning about this issue. And I will be lecturing on Tuesday at 12:30 in place of on Friday. On Friday, next Friday, we don't have, I will not be able to lecture on Friday. I'll be out of town. So instead, I will be teaching on Tuesday. If it's okay with you, I'll do that on Tuesday. So I have another section, the Turkish section as well. And I also I agreed with the student. The student didn't complain about it. They said yes, they can take the course on Tuesday. Even if you you cannot possibly participate in the lecture lively, you can watch the videos I will be sharing on YouTube also. If you can't make it to participate in the lecture on Tuesday at 12:30, you can just watch the lecture videos I'm sharing on YouTube. Is that okay with you? Would that be okay if I lecture on Tuesday at 12:30 in place of Friday?
It is okay, teacher. Have a nice travel.
Okay, thanks a lot. It's very kind of you. So we can get back to the lecture. So, do we have a WhatsApp group? Can you also possibly share this announcement with your friend for those who are not watching the lectures and try to access the lecture on Friday mistakenly, accidentally, and don't see me in the Zoom room, in the Zoom class, just to avoid that, to avoid students to participate on Friday. And can you
WhatsApp grubu
possibly tell
açıldı
them?
mı bilmiyorum ama hocam.
Can you just write it on the WhatsApp group if we have established already? Can you do it for me, please? And you make the announcement. Tell your friends that the lecture will be canceled on Friday and it will be on Tuesday. Instead, the lecture will be held on Tuesday at 12:30 at the same time. Can you just tell your friend?
Tamamdır. Ben söylerim herkese.
Okay, thanks a lot. So I can get back now to the lecture. Yeah, I'll have an example from the book you're following for this lecture. Let me see. I have worked out number one in the previous in the Turkish section. I translated this exercise. I'm gonna copy this exercise for you. So this is, there you go. The good thing is I don't need to translate the exercise here. It's already in English. It's good for me. Okay, resize it back. An example what is waterfall heights. Is there, the question is there a
Hocam biz Zoom ana sayfasında kaldı bizim görüntümüz ama.
Okay, I'm so sorry.
Tamam.
Let me share the screen. There's a lag now. It just show the example, right? It doesn't, you can't see. I said, yeah. Now you can see. Do you see?
Yes, teacher.
Example waterfall heights. So the question is there a significant difference at alpha equals 0.10 level of significance in the mean heights in feet of waterfalls in Europe and the ones in Asia? The data are shown there, right there. So the question is, as I told you, if it tells you whether there is a significant difference, so you will automatically establish the hypothesis, the alternative hypothesis where the claim is at double-sided. So you will automatically establish the hypothesis as double-sided. Let's get the solution here, right here. Write the solution from there. Okay, so the hypothesis we will construct here would be H null, mu1 equals mu2, and the alternative mu1 is not equal to mu2. That's how you establish the alternative hypothesis. So the alpha level is 0.10, and the size of the sample sizes, you can easily just count how many observation you have from Europe and from Asia, the number of waterfalls. You measure the heights, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 is 9 equals 9, and in 2 is also 9 if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's also 9, and 2 is 9. So the thing is, to test such hypothesis, you would need the x1 bar and the x2, the sample variance also, an x2 bar and s2 square. So you would need those two measurements before you get to calculate the pooled variance. So if you have a scientific calculator, you just enter the data set. Probably you have learned how to use your calculator in the previous semester, you can easily do it in the examination using your scientific calculator. It's allowed in the examination. But if you don't have a scientific calculator, it will be hard in the examination to calculate the mean, because you will sum up and divide. Especially the variance is hard to calculate. So you would need definitely a scientific calculator where you can easily perform statistical calculation. What I'm going to do, I will perform this calculation in Excel. I don't want to use a scientific calculator at the moment. I will automatically perform such calculation in Excel easily. Can do it easily in Excel. Let me see. So I have an Excel here, right here. I can just type here. Yeah. So did the first one, X1, I'll type X1 here. This is X1 and X2. If you have an Excel, it's easy to perform such calculation in Excel, but in the examination, you're not allowed to use a computer or anything like this. You'll have to use your own calculator. So just to be quick, I'm using Excel. I'll enter the data set right here, 487, 470. The next one is 900. The next one is 1246, 1312, 345, 1385, 984, 820. Okay, I completed the first sample, and the second sample, I'll just enter the second sample. 614, 1137, 350, 722. Okay, 320. I have another one, 722, 964, 830, and 1904. Okay, I perform entering the data set this way, and I can type here the mean, the standard deviation, or the variance. I will write the variances. Pooled variance, sample sizes, okay, sample sizes 9 and 9. Right here, you can write the pooled variance. Okay. I just need to write the function in Excel to get the calculation done automatically. I will write the function. The function start in Excel with equality equals. Since I'm using the Turkish version of Excel, I'm using the Turkish equivalent function, which is ortalama. But if you're using the English version, the mean is calculated by the average function. There is an average function. It's called average, the English version. So once you type the function, you open a bracket and you just specify, select the data set you want to take the sample means. So there you go. I easily get it right there. And I'm getting the next one because I use the autofill, autocomplete function of Excel. I don't need to write the second function for the second sample, X1 and X2. I don't need to do that. Okay. Okay. You just type bold. Yeah. Okay, the variance you need to calculate the sample variance, which is there is a function y dot s. So that the function is the same, the English and the Turkish version is, if you select the second one, it will be the sample variance. If you pick up the first one, it will be the population variance. The population variance is different because the division is not n minus one, it's n directly. So it's different. So I select the data set also to perform such calculation of the variance. And I can use the autocomplete function of Excel to calculate the second one, the second variance. The sample variance is this one. And the pooled variance, I'll have to write a function for the calculation of the pooled variance. I have 10 minutes to go. I'm trying to finish this exercise within 10 minutes. Okay, the sample variance equal, I will type within bracket, and I will also have another bracket, and 9 minus 1 times s1 square. S1 square is this one. Multiply this, plus I'll have the second one, and this one minus 1, 9 minus 1. And this divided, multiplied by its variance, this one. And I'll have to close the bracket now and divide it by n1. N1 is 9. Yeah, B14 plus C14 minus 2. That's how you get the pooled variance. That is the pooled variance. Okay, I can write everything here within my lecture file easily. So I will prepare my lecture note accordingly. Okay, x1 bar is right there, 883. So 800, this one right here, 883.22. Okay, S1 S square is 149,000. It's a big number, 149,000. 887.7. Okay, the second sample mean is 840.33 and another double 3, and S2 square is 2,200. No, 228,150.5. Yeah. Okay. Okay, the pooled variance, remember, I'm going to copy the pooled variance, the formula for the pooled variance. Yeah. There you go. So I'll substitute whatever I need right here. Okay. N1 is 9 minus 1. S1 square is 149,887.7 plus 9 minus 1 times the second variance, which is 228,000. 150.5. Extend this one. Okay, this is divided by 9 plus 9 minus 2. And the result of the pooled variance is already right there. In Excel, it's right here. It's already calculated here. So I can directly write the result of the pooled variance, which is 189,000 and 19.1. Okay. So that's the pooled variance, and I can now easily perform the T-calculated statistics. I'm gonna bring back the T-calculated statistics. Yeah, copy this, place it somewhere here. Okay, this is the T-calculated statistics. Let me substitute the result. Yeah, there you go. X1 bar is right here. X1 bar and X2 bar as this one, 840. So I can easily substitute the result 883. Point double two, another double two minus 840 point double three, another double three. Okay, the pooled variance is 189,019 and times reciprocal 9 plus another reciprocal 9. This is within the square root. Okay, so if you perform such calculation, I will do the calculation in Excel. I'll get back to my Excel file to perform such or you can try yourself if you have a calculator. You can do it yourself. The T-calculated statistics, T-calculated statistics. I'll write the function. In the denominator part, I'll have the first mean minus the second mean, close the bracket, and divide it by the square root. So you have a square root. The function of the square root of Excel, if you're using the English version, it will be SQRT, but I'm using the Turkish version, so I have automatically the function karekök. There you go. And I need to write the pooled variance. There it is, the pooled variance, B and B 13 times, I'll have reciprocal 1 divided by 9, reciprocal, plus you'll have another one, 1 divided by the second one, and I close the bracket, and there you go. I need to find out whether I'm mistaken with something. Let me see. Yeah, no problem. Yeah, I have correctly write the formula for the calculation of the T statistics, so it's correct. That's fine. It's 0.20. I can diminish the decimal places. It's too much here. I like to have only 4 digits. Yeah, there you go. Okay, only 4 digits. So the calculated statistics, you can easily write the result, which is 0.2093. So that's the T-calculated statistics, and you need to compare this result with the critical value from the T distribution table. So the degree of freedom, in this example, the degree of freedom would be EF equals N1 plus N2 minus 2, which is 9 plus 9 minus 2, that is 16. So the critical value equals T, the degree of freedom, comma, alpha divided by 2, because this is a double-sided hypothesis we constructed, double-sided, so we have to split alpha into half. It's the same as what we did in the previous week or 2 weeks lecture ago. So this would be T16 0.05 level of significance. I'll bring this value from the T table. I have a table, T distribution table, I already shared with you. Okay, look, this is the degree of freedom. I would need 16, and there I would need the alpha level 0.05 or 0.10 for the two tail. So I get from this column, and I'll intersect this row, and this is the critical value I would be using for testing such hypothesis. So it's one